Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So if you are seeing this channel for the very first time, welcome. Welcome to our community, our maths community, right? In this channel, we basically go through pure maths as well as mathematical literacy content. Okay, so if you know that you're struggling with mathematics, okay, in grade 8, grade 9, grade 10, grade 11, grade 12, right? Please make sure that you are subscribed to the channel. But I'm guessing if you've clicked on, this lesson, you are currently in grade 9 and you just want to, get an idea of what you need to go through as you are preparing for your grade 9 November exam, right? So please take note, okay? When you are preparing for your November examinations, right? Especially if you are, looking at past papers, okay? Past papers just look at, a small percentage of, particular concepts that you've done in school, right? So you need to ensure that as you are preparing for your November exam, right, you have the scope, okay, that you have been given by your school, by your teachers, okay, and you are using that scope to revise concepts that you've gone through throughout the whole year, right? And then once you've gone through those concepts, okay, then you want to basically check to see if you're understanding those concepts by just going through past papers. Guys, we don't use past papers to, study. Okay, we use past papers to revise concepts that we've already learned in school. Okay, so you can't just solely focus on past papers. Okay, you still need to look at the scope and check, have you covered all of, the concepts that were given to you in the scope. All right, okay, so please make sure that before we get started with this lesson, you are subscribed to the channel. Okay, please also make sure that you click on the notification bell so that you get notified every single time I upload a YouTube lesson. Okay, and also guys, please don't forget to give these videos a huge thumbs up. It really helps. It goes a long way in helping the channel to reach more learners that want to better their mathematics marks. Okay, right, so let's get started. So before we even get started, right, with this paper, so obviously we're going to be looking at this provincial exam that was written by grade 9 Gauteng province learners in November 2022. Okay, please note, all right, this is just us using this paper to revise concepts that you should know for paper 1. Okay, but just to give you like a brief breakdown of what you need to know for paper 1, okay, please, when it comes to paper 1 is your paper that deals with your algebraic expressions, your algebraic equations, your factorizations, your graphs. Okay, it deals with your your number theory, so your whole numbers, integers, exponents, scientific notation. It deals with your patterns, your number patterns, right? So your linear patterns, your geometric patterns, right? It also deals with financial mathematics, right, in some cases as well. Okay, so please make sure that you have a look at the scope that your teacher has given to you, right, and you're going through those concepts to the T, right? And also make sure that you also look at past papers to help you revise. Okay, so let's get started. Okay, the first thing that I always say, okay, when you are given an exam is that you always need to give yourself time to have a look at the instructions that are given. Okay, especially when it comes to maths. Okay, you are given clear instructions when it comes to the diagrams that are used in the paper, when it comes to how you also need to round off answers in certain questions. So you need to always make sure that you are reading the instructions that are given to you, because those instructions are going to guide you as to how you need to go about answering the questions that are given to you. All right. Okay. So we're going to start with section A. Right. And, you'll see that with section A is basically a multiple choice. Okay. So nice and easy. It's just getting us, warmed up. And with these multiple choice questions that are given to us here, in section A, it's just a combination of, the topics, that we have looked at, okay, for paper 1 throughout, the year, which is term 1 as well as term 2. Okay, so let's see. Question 1, answer the following questions by circling the letter next to the correct answer. So question 1.1, how many terms are in the expression? Right, so we're given an expression here, and they are asking us, in this given expression, how many terms do we have in this expression? Okay, so I just want to highlight something, okay, especially when you're given a question like this, where they give you this term, okay, that is a combination of, numbers, okay, or that has combined numbers by using your brackets. Okay, please note that if you're given a term, if given, a term like this actually counts as one term, okay, because those brackets, okay, have actually combined, okay, all of those terms. So we look at that term as one term. Okay, so now if we had to count how many terms we have in this expression, I just want to show you something as well here. Okay, because we are also given, okay, we are given here, you've got negative, open bracket, 3x minus 1 to the power of 3 plus x, okay, minus, this is the same as saying 4x divided by x squared, right? So because then you also have that 4x divided by x squared, right? That division has also now combined those two, right? So if you're now looking at how many terms we actually have in this expression, you actually have one term. Okay, I'm going to just put a rectangle. This is term number 1. Okay, this is term number 2, and that is term number 3. Okay, so the number of terms that we have in this expression is actually 3 terms. So the answer there is B. And then let's have a look at question 1.2. Now, it's question 1.2. It's saying, which of the following is not an example of a rational number? Okay, so before we look at question 1.2, I just want us to focus on, this, all right? So we know that, okay, when you're basically looking at, the number theory, okay, right? We know that your real numbers, okay, your real numbers consist of, number 1, rational numbers, okay, number 2, irrational numbers, okay, number 3, integers, number 4, whole numbers, number 5, natural numbers, right? Okay, so under this umbrella of real numbers, okay, you've got the following numbers: your rational numbers, your irrational numbers, your integers, your whole numbers, as well as your natural numbers. Okay, so what are rational numbers? Okay, so rational numbers are, numbers that can be written as a fraction. Okay, these are numbers, for example, that terminate. So you find that it's going to be 0.22. Okay, right? And these are numbers, for example, if it's like a, decimal number, okay, the decimals are repetitive. Okay, so for example, it's going to be 0.2323232323. Do you get what I'm saying? Or 0.222222. Do you get what I'm saying? So those are example of your rational numbers. So rational numbers are numbers that can be written as a fraction. Okay, these are numbers that terminate, or we can even say repetitive decimals. Right, so I'm just going to give e.g. example, right? Numbers that can be written as a fraction, like 3 over 4. Okay, if you actually even check 3 over 4 on your calculator, okay, you'll see that it gives us 0.75. Okay, so do you see that it's a number that terminates, and that 3 over 4, or that 0.75, is a value that can be written as a fraction. Good. Okay, another example, 0.6. Another example, 0.222, it recurs. Another example, 0.232323, okay, and the 23 keeps recurring. Also, what's very important that you need to know about rational numbers, okay, your whole numbers are also considered as rational numbers, okay, right? Your natural numbers are also considered as your rational numbers, and your integers are also considered as your rational numbers. Okay, so if you actually look at it as a whole, right, your rational numbers are your whole numbers, so the numbers that start from 0, 1, 2, 3, or natural numbers 1, 2, 3. Okay, integers from negative infinity to positive infinity. All of those numbers can be considered what your rational numbers. So please be aware of that there. Okay, so your all integers, whole numbers, natural numbers are considered as your rational numbers. Okay, cool. Now, what are irrational numbers? Okay, these are your irrational numbers, are numbers that cannot be written as a fraction. So obviously, if it's something that does not suit, okay, the definitions that we gave to the rational numbers, okay, then it means that that number is an irrational number. For example, okay, like I said, irrational numbers are numbers that cannot be written as a fraction. These are numbers that basically give you non-repeating decimals, right? Okay, so your irrational numbers, these are numbers that cannot be written as a fraction, okay, and they've got non-repeating, okay, decimals. Okay, so an example of your irrational number could be your pi. Remember, if you take your calculator and you say shift pi, do you see that you'll get a number that's like 3,1415926? Do you see that none of those, decimals are repetitive? Okay, we call that number an irrational number. Okay, or 1,695248. We call this number also a irrational number. Or, okay, if you say the square root, okay, of 8, you'll find that the square root of 8 is also, you'll find the square root of 8 is also an irrational number, because if you take the square root of 8 and you press equals and you press the SD button, you're going to get the answer as 2,828427. Do you see? Okay, so that number, the square root of 8, cannot be written as a fraction. And if you put that value in the calculator, you're going to get a number that is actually, a value that contains non-repeating decimals. Okay, none of those decimals that are given to us in that value are repetitive. Okay, it's completely different. That's 828427. Okay, none of them are repeating, none of them are recurring. Okay, therefore that makes it an irrational number. Now, what are integers? Okay, so integers, these are numbers that start with a negative number and include all natural numbers. Okay, so for example, okay, these are numbers. Okay, so actually, if I had to define what an integer is, right, it's starting from negative infinity to positive infinity and basically including all your natural numbers. Okay, so for example, right, I can say -2, okay, -1, 0, 1, and 2. Okay, so these numbers, okay, are okay, so -2, -1, 0, 1, 2, all the way to positive infinity. All of these numbers are considered integers. So it's very important that when you're thinking about integers, yes, you're thinking of, yes, I'm looking from negative infinity to positive infinity. Okay, I'm actually including all natural numbers, but it needs to be whole numbers. Okay, so you can't have, decimals. Okay, an integer can't be, right, a value that contains a decimal. Okay, you can't say -2.1 is an integer. Okay, if we're focusing on numbers from negative infinity to positive infinity and whole numbers, okay, throughout that timeline, then we consider those numbers as integers. Cool. Now, what are whole numbers? Okay, so whole numbers, okay, start with 0 and include all natural numbers. Okay, so e.g., you just need to know that if I'm talking about whole numbers, I'm starting from 0 and I'm including all natural numbers. Okay, right, so obviously I'm continuing here, and then obviously here we are continuing there. Okay, all right, so this is just an example of whole numbers. You're starting from 0, going all the way to positive infinity, taking note of the fact that we don't have, right, any negative values when we are talking about whole numbers. Okay, and then lastly, what are natural numbers? When you're talking about natural numbers, we are just saying that we have numbers starting from 1 going all the way to positive infinity. Okay, taking note of the fact that these need to be whole numbers. Okay, obviously no decimals. All right, so it's very important as you walk into paper 1, we understand what are real numbers. Okay, what are rational numbers, irrational numbers, integers, whole numbers, as well as your natural numbers. Okay, and then obviously, okay, if we just now diverting a bit, okay, from this, if I'm talking about, okay, your non-real numbers, okay, I'm talking about, for example, e.g., if you take 5 divided by 0, you're going to get a value that is undefined, that is considered as a non-real number. The square root of -4, okay, you can't have a negative number under the square root. So those types of numbers, we consider them as your non-real numbers. Okay, so it's very important that you revise this concept as you are preparing for your paper 1. All right, I think we're ready to now look at this question here. Now they're giving us a question, and this question is saying, which of the following is not? Okay, right, so I always say this to my students: you all the time need to ensure that you highlight the keywords. And obviously here they've kind of highlighted, they actually have highlighted the keywords for us, so to make our lives a bit easy. So which of the following is not an example of a rational number? So now remember what I said. I said if I'm talking about a rational number, okay, I'm talking about a number that terminates. I'm talking about a number, right, that maybe has decimals that are recurring, right? I'm talking about a number that can be written as a fraction. Okay, but now if I want to identify a number that is not a rational number, that means that it's a number that if I put that number into my calculator, it's not going to give me, right, decimals that recur. It's a number that is probably going to, give me values, okay, that are non-repetitive. Okay, so we can, and then remember, I also said that your rational numbers, under the umbrella of your rational numbers, an integer is a rational number, a natural number is a rational number, a whole number is a rational number, right? So we need to take that into consideration, when we are looking at the following. So let's look at this one, number 5, because they're saying which of the following is not a rational number. So we know that 5 is definitely a rational number because we said that your natural numbers and whole numbers are also considered as rational numbers. 5. Then you take square root of 5. Is square root of 5 a rational number? Okay, if you take the square root of 5, you'll see that you get an answer of, this basically gives us an answer of, let me just show you, 2,23, 6067977. Do you see? So what are we noticing about this number? We are noticing when you're looking at these decimals that are given to us there, they are non-repetitive. Do you see? We're not getting a 2 comma 3 3 3 3 3 or a 2 comma 2 3 2 3 2 3. Do you see? They're non-repetitive. So already that is telling us that this square root of 5 is definitely what? A irrational number. Okay, let's continue. 2,5. 2,5 is a rational number because it terminates. Okay, 2,5, that's it, terminates. It's a rational number. Lastly, square root of 1 over 25. Okay, that is also, you'll check. If you take your calculator and you put the square root of 1 over 25, you'll see that you're going to get 1 over 5, which is a fraction. And we know that if a number can be written as a fraction, okay, that basically means that it's a rational number. If you even continue and press the SD button, you'll see that you get 0,2. All right, so we can definitely see that D is also a rational number. So which of the following is not an example of a rational number? We can already see that B is not a rational number, and it's not a rational number because what we basically get that the square root of 5 gives us a value, okay, that right gives decimals that are non-repetitive, therefore that makes it a irrational number. All right, do you see why it was important that we started there, okay, before we look at the questions, right? So please make sure that you are listening attentively, okay, to the explanations that I'm providing to you. Okay, right, let's look at question 1.3. Choose a statement that describes how to determine the next term in the pattern. Right, so here we can see that the concept that is, being assessed here, right, is number patterns. Okay, so remember what I said, when it comes to the multiple choice questions, right, in section A, right, they just throw in all of these, concepts that you've, looked at in term 1 and in term 2, right? And then obviously they just put it in one. And so usually easy questions, things that you can just immediately remember. Okay, don't be something hard for you to remember. Right, now let's look at this. We're given this number pattern. Remember, when you're looking at number pattern, you always want to ask yourself, how did they move from term 1 to term 2? From this term to that term, from that term to that term, from this term to that term. So what are we noticing is that as we move from term 1 to term 2, you can check for yourself. All right. Okay. It's getting smaller by a half. Okay. So if I take, you'll actually notice that, right? As you move from term 1 to term 2, it's actually getting smaller, okay, by what? A half, right? So it's like you just, dividing. You're just dividing each term by 2, or you can even look at it this way. You are multiplying each term by a half, right? So let's see. If I say this 1 and I divide by 2, do you see the first one divided by 2? I get the second term. And I take the second term, okay, a half, and I divide by 2. What am I going to get? Remember, okay, if you're dividing by a number, that's the same as multiplying by its reciprocal. So it's multiplying by 1 over 2, which is equal to 1 over 4, right? So it's the same as just saying each time. You can even just quickly do this in your calculator. If I take a half and I divide by 2, I get 1 over 2. And if I take 1 over 2 and I divide it by 2, I get 1 over 4. If I take 1 over 4, I divide it by 2, I get 1 over 8. I think you're getting my point. Or, okay, you can even look at it this way, all right? Okay, what are we doing? Okay, remember, if what I said, if I'm dividing, I'm just going to focus on the second term. If I say 1 over 2 and I divide by 2, okay, this is an important concept. When it comes to, fractions and dividing fractions, you need to remember this, okay? Right? If I'm dividing by a number, that's the same as multiplying by the reciprocal of this number. So what's the reciprocal of 2? 1 over 2. Okay, so we can actually see that what they're actually even doing here, it's the same as just saying I'm multiplying by a half. Do you see? 1 multiplied by half gives us a half. 1 over 2 multiplied by half gives us 1 over 4. 1 over 4 multiplied, I think you get the point. So we can see that then the correct answer there is going to be D. Okay, right. Please remember this concept there. Right. And then question 1.4, right? They're asking you to obviously complete this, right? Obviously, I love showing how we get to the final answer. Okay, so if you've got 13, or you've got the square root of 13 squared minus 5 squared. Okay, this is, if you have to simplify this, right? 13 all squared gives us 169 minus 5 squared, right, gives us 25, right? And that is equal to, I'm just going to simplify what's happening under the square root. Okay, I'm getting 144, right? The square root of 144. And then from there, the square root of 144 is equal to 12, right? So we can already see that the correct answer there is 12. But obviously, if it's just a mark, if it's just for 1 mark, okay, you can just quickly just punch this into your calculator, and then you'll get that the answer is 12. But I showed you how you would even have to, show the solutions for this question if it was, a question that said something like, show without the use of a calculator, right? What the square root of 13 squared minus 5 squared will be. Okay, so yeah, right? But then the final answer there should be 12. So you can just directly put that into your calculator because it's just for 1 mark. Now, let's look at question 1.5. We are given the following a table. Right, you've got X values, okay, and input values, and you also have output values. Now they're asking us to identify the formula that shows the relationship between X and Y in the table that is given above. Right, so all the time, right, when you want to determine the rule, okay, that is used, right, for us to determine the relationship between X and Y values, you can either think of, remember, the minute you've got X and Y values, right, you can always think back to your patterns. Okay, and what I normally do is that if I am looking at trying to determine the rule, right, for a particular pattern, okay, I always just look at your output value. Okay, so I look at the output value, okay, right, and then we can see that our output values are, right, -9, -4, 1, and 6. And then I try to see, do I have, right, a constant difference? How did I move from -9 to -4, right? Then you'll see that from -9 to -4, right, I added 5. From -4 to 1, I added 5. From 1 to 6, I added 5. So we can already see that if we're looking at, just the Y values, we can see that we've got a constant difference of 5, right? So now remember, okay, if you've got a constant difference and you're thinking back to sequences, okay, we always just say, remember, it's Tn is equal to your constant difference times n plus c. That's the formula that we use if you are, given a linear sequence, right? So here, same thing, same concept here. It's just that now here, our Tn is just going to be our y is equal to the constant difference, okay, right? Okay, multiplied by our x, okay, which is our input value, plus c. Okay, now, right, what do we need to do now in this case? We already know that the constant difference is 5. Okay, so I'm just going to say y is equal to 5x plus c. Now, what am I trying to now determine here? I'm trying to determine what is the constant, because you can already see that now from what we can already see, okay, it's starting to look like the D is the correct answer. But now we need to now check if D is in fact, right, the correct answer. So what do we do here? Right, we already know that our y is -9 is equal to 5. So when your y is -9, what is your x? -2 plus c. Remember, I'm just trying to determine what is the value of c. Okay, then I'm just going to say -9 is equal to 5 multiplied by -2 is -10 plus c. Then I'll say -9 plus 10 is equal to c. I think we should all be happy with how we got to a plus 10. Okay, remember, if this negative jumps the equal sign, right, then it becomes a positive. Then -9 plus 10 is equal to 1. So we can see that the c is actually equal to 1. Therefore, okay, the formula that will show the relationship between x and y is going to be y is equal to 5x plus 1. Okay, that is the formula that is going to show that relationship. And we can see that the correct answer there is D. So you need to remember, you need to think back. You need to make links. Okay, we need to see, oh, okay, right? If we're dealing at trying to determine a rule, okay, we need to think back, right, to what we learned when it comes to our patterns, okay, what we learned when we're looking at patterns. And all the time, you look at your output value, okay. Take your output value, right, write it as a pattern, then you try to identify, do I have a constant difference? If I have a constant difference, remember, then we use that formula, Tn is equal to Dn plus C. But remember here, we're not really working with a pattern, right? We're not given a pattern, we're actually given x and y values. So that's why then I've just changed the Tn as y is equal to dx plus c. Then we just substitute there. I've already explained that the d just stands for the constant difference. And then I think there we should be fine. Okay, and that is section A, done and dusted. All right, now we're going to look at question section B. All right, and if we just quickly, just have a look at what we are going to be looking at when we are looking at section B, right? Section B deals with ratios, right? We're going to be looking at, ratios. We are going to be looking at, finding the lowest common multiple and the highest common factor using prime factorization, right? Okay. And then we are also going to be arranging values in ascending order. We are going to be simplifying without the use of a calculator. We're also going to be assessed, right, on, the laws, the exponential laws, right, that we have gone through, right, in term number 2, okay, and then we're also going to be looking at patterns, right, in question number 5, right, and then functions and relationships as well there. Okay, and then question number 6, we're going to be looking at your algebraic equations and expressions. Okay, and then question number 7, we are going to be looking at your graphs. All right, question number 8, algebraic equations, and then we've got a nice problem solving question that is given to us there. Okay, right, cool. Now let's look at question 2. Now, if you're given a question where you are asked to write a number in simplified or in its simplest form. Now we need to remember when it comes to this question, right? If they're giving you a ratio and they say now you need to write that ratio in its simplest form, all that you need to do is that you need to identify the factors of that first number. Okay, what are the factors of 21? What are the factors of 35? And then from those factors, okay, you are going to identify what is the highest common factor. Then you divide all through by the highest common factor. Okay, that is the procedure, okay, that we use when you want to, write a ratio in its simplified form. Right, now if we look at number 21, right, so what are the factors of 21? It's 1, it's 7. Okay, I think I've skipped one. It's 1, it's 3, it's 7, and it's 21. Okay, so I'm hoping I didn't leave anyone out, right? And then what are the factors of 35? Remember, when I talk about factors, I'm talking about numbers that can go into 35 without leaving a remainder, right? Factors of 35: 1, 5, 7, I think 35. I hope I'm not leaving anything out. Now, when you look at these factors, from these factors, which factor is the highest common one when you look at both for 21 as well as 35? Okay, you'll see that 7 is the highest common factor. Right, so now that we see that 7 is the highest common factor, that basically means that now I'm going to divide this 21, okay, by the 7. This 35 by the 7. Therefore, 21 divided by 7 is going to give you 3 is 2, right? And then 35 divided by 7 is going to be 5, right? So therefore, 21 is 2. 35 written in its simplest form will be 3 is to 5. Also, a nice quick way that you can just do this, okay, on your calculator, because I mean, this is just for 2 marks, okay? Just take that. Remember, this 21 is to 35 can, be written as a fraction. A ratio, okay, can be written as a fraction. How? You just say 21 divided by 35. So in your calculator, 21 divided by 35. Then you're going to get an answer of 3 over 5. So meaning that now I'm just going to write the 3 divided by 5 as a ratio. So which is 3 is to 5. Okay, so here I'd rather prefer that we just use our calculator, okay, to get that final answer. Okay, because it's just for 2 marks. You don't want to be spending too much of your time going through finding the factors of 21 and 35, then finding the highest common factor, then divide it. It's going to take forever because it's for 2 marks. If they said show calculations, maybe then, okay, then you would be required, okay, to show all these steps, showing, the fact that, these are the highest, the factors, and then finding the highest common factor. But in this case, because it's just for 2 marks, honestly speaking, you can just use your calculator the way that I've explained to get your answer. Cool. Now let's look at question 2.1. Now this question is saying we need to use the ladder method to determine the prime factors of 36. Okay, so if we're talking about, prime factors, boys and girls, right? We are trying to basically determine, okay, what are the prime factors or prime numbers that I need to multiply together to basically get my 36. Okay, so that's basically what I'm trying to do. I'm just trying to determine what are the prime factors, okay, that I need to multiply together for me to get 36. And then remember, guys, if we're talking about, prime numbers, we're just saying that a number that is divisible by 1 in itself, right? So that's basically what we're trying to do. So now if you have to now use the ladder method, okay, to determine the prime factors of 36, what we always do is just start with 2, okay, right? If I say 36 divided by 2, what am I getting? So if you take 36 divided by 2, you're going to get 18. Then I continue. 18 divided by 2, because 2 can still go into 18, right? You're going to get 9. Now, unfortunately, you can't say 9 divided by 2 now, okay, because 2 cannot go into 9, all right, okay, hence factors, okay, it has to be a number that can go into that number without leaving any remainders. So we can't use 2 anymore, so we're going to go on to 3. So if I say 9 divided by 3, what do I get? I get 3. Okay, and then if I say 3, I'm still continuing. Divided by 3, what do I get? I get 1. Right, so remember, if you are basically trying to get the prime factors of a number, you want to get to a point where you've got like you've got a 1 there at the end. Okay, so we've basically found the prime factors of 36. So it's going to be what? It's going to be 2 times 2 times 3 times 3. Okay, and then because they said that we need to write our answer in exponential form, you can't just leave your answer like that, okay, because they said it needs to be in exponential form. So it needs to be 2 to the power of something times 3 to the power of something. Okay, so it's going to be 2 to the power of 2 times 3 to the power of 2. Okay, so therefore, okay, the prime factors, okay, of 36 is 2 to the power of 2 times 3 to the power of 2. So these are the prime numbers, okay, that I need to multiply together, okay, to basically, or the prime factors that I need to multiply together to basically get 36. You can even check. If you say 2 to the power of 2, okay, times 3 to the power of 2, you'll see that you actually get 36, okay, and that is our final answer. Now, question 2.2.2, it says the number 540, okay, the number 540 as a product of its prime factors is 2 to the power of 2 times 3 to the power of 3 times 5. Now they say determine the lowest common multiple and highest common factor of 36 and 540 using the information given above. Right, very, very important question that I'm going to do here at the bottom. Okay, so this is question 2.2.2. Okay, so we want to basically use prime factorization to help us determine the LCM and the HCF of 36 and 540. Now remember, we already found that 36, the prime factors of 36 is 2 to the power of 2 times 3 to the power of 3. 3 to the power of 2. So 2 to the power of 2 times 3 to the power of 2. Then we are also told that, right, the prime factors, okay, of 540 is 2 to the power of 2, 2 to the power of 2 times 3 to the power of 3 times 5, right? That's given to us there. Now, if they say now, they want you to determine the lowest common multiple, right, and the highest common factor using prime factorization, right, what do we need to do? All right, so the steps that you need to follow, right, when it comes to now, being able to find the lowest common multiple as well as the highest common factor, right, of a number using highest prime factorization, like you first wanna, circle the powers, right, that have the same base. Okay, then after you've circled the powers that have the same base, when it comes to the lowest common multiple, okay, you're going to just focus on the powers with the highest exponent, okay? And then when it comes to the highest common factor, you're going to focus on the powers, right, with the lowest exponent, right? Okay, remember, if I'm talking about a power, okay, a to the power m, this is considered a power, okay, right? This whole term is considered a power, right? Okay, the a, only the a, okay, that is considered what? My base. And then my m, that is considered what? The exponent. Right. So if I'm saying, if you want to now identify the lowest common multiple, and you want to now first start off by circling, right, the powers, okay, that have the same base, okay, that's basically what we're going to do. So I'm going to start off by finding the LCM. Remember, we want to look for the powers that have the highest exponents. But I first want to start off by circling the powers that have the same base. So you can see that the powers that have the same base, okay, do you see? This is a power. This is a power. So the powers that have the same base, right, is these ones. Okay. Also, powers that have the same base, this one. Okay. And I always just use this trick because we've got 5 here, right? Remember, if you just have a number that technically doesn't have an exponent, basically says that it's just 5 to the power of 1. Okay, but because we've got a base or a power that has a base of 5, it would make sense to also just put a power, okay, that also has a base of 5 for this 36, okay, because now it makes it easy for us now to not make unnecessary mistakes when we are trying to look for, LCMs and HCF, okay, right, using prime factorization. Remember, even if I say 5 to the power of 0, remember, anything to the power of 0 is equal to 1. So that's the same as just saying, even though I've said it's 5 to the power of 0, but it's the same as just saying, 2 to the power of 2 times 3 to the power of 2 times 1. Okay, I haven't really changed that. Okay, right, so I'm also going to, circle that thing. Okay, right, so now that I've circled the powers that have the same base, remember with the LCM, I want to just focus on what? I want to focus on the highest exponents. Okay, so what does that mean? So therefore, for my LCM, okay, what will the LCM be, right? Using prime factorization. Okay, so what is the highest exponent there? Right, the highest exponent, if you're looking at the 2's, it's 2 to the power of 2. Okay, I'm just going to use yellow. 2 to the power of 2 is, it's the highest. Okay, when you're looking at those powers there. Okay, so it's 2 to the power of 2. Okay, multiplied by, which one is the highest, which power has the highest exponent there? Okay, do you see it's 3 to the power of 3? So 3 to the power of 3 multiplied by, do you see now which power has the highest exponent there? Do you see why it's very important to add that there? Because if you don't, you can make a mistake of thinking that you must exclude, right, that 5, or you mustn't look at it. Okay, it's 5 to the power of 1, because 1, okay, the exponent 1 is higher than the exponent 0. So when you're trying to find the LCM using prime factorization, you are going to just circle the powers that have the same base. Now, once you've circled the powers that have the same bases, okay, then from there you want to focus on the powers that have the highest exponents. Okay, then you're just going to multiply those together. All right, okay, then you'll see that if you punch this into your calculator, okay, you're going to get 108. So the LCM, okay, of 540 and 36 using prime factorization is 108. Good. Now, let's find the highest common factor. Remember what I said here? Right here, we're going to focus on the powers that have the lowest exponent. Okay, so we can see here 2 to the power of 2. It's the same. Okay, so I'm still, they've got the same exponent, so I'm still going to use that 2 to the power of 2 multiplied by, okay, 3 to the power of 2. Do you see that there? This one is the lower exponent. Okay, multiplied by 5 to the power of 0 or 1. Okay, right. Then from there, this is the same as just saying 2 to the power of 2 times 3 to the power of 2 times 1, okay, which is equal to 36. So the highest common factor, right, of 540 and 36 is equal to 36. Okay, very, 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 very important concept there. Okay, so I'm just going to write that answer there. Okay, so that is our final answer there. Now, let's look at question 2.3. Now, with question 2.3, okay, you must be very careful with this question. Okay, this question basically deals with your, the concepts that we've learned in direct and indirect proportion. We are given a situation, right, where they say 12 contractors can build an RDP house in 7 days, right? So they're saying that 12 contractors, okay, can build a house in 7 days. Okay, right? Now they're asking us how many contractors, okay, how many contractors, okay, working at the same rate will be needed to build the house in 4 days. Okay, so when it comes to this question, right, the reason why I'm saying that we actually going to use your concepts that we've learned in your direct and indirect proportion is that if you think about this, situation in a practical sense, okay, the more contractors you have, right, the more contractors you have, the less days you would need, or the less days it will take you to complete the job. The less contractors you have, the more days it will take you, to build these RDP houses. Okay, so we can actually see that, right, this question is actually tackling an indirect is actually tackling, the concepts that we've learned in indirect proportion. Okay, so it would be incorrect for us to think that, okay, I'm just supposed to use ratios in this way where I can just cross multiply, all right, and solve for x. Because by doing that, right, then you technically be saying, okay, you'll technically be saying the more days you work, okay, the more contractors you'll need, basically. Okay, so in this case, that is why we just need to use what we've learned in your direct and indirect proportion. And remember what we said. Okay, we said that in indirect proportion, your x multiplied by y is equal to, right, your constant. Okay, this is the equation that we use when you are dealing with an indirectly proportional relationship. And obviously here we're dealing with an indirectly proportional relationship because the more contractors you have, the less number of days it will take you to build these RDP houses. The more contractors you have, the less number of days it will take you to build these RDP houses. Okay, so now we already know that. Okay, if you've got 12 contractors multiplied by 7 days, that should equal 4 days multiplied by how many contractors will you need? Okay, then from here, all that we need to do, we need to just solve this equation for x. So if you divide both sides by 4, divide both sides by 4, you'll find that x is equal to 84 divided by 4. Therefore, x is equal to 21 contractors. Okay, you'll see that you actually need 21 contractors. Okay, all right, because we already know that if you're dealing with an inversely proportional relationship, okay, when one value increases, okay, or when one variable increases, the other variable decreases, okay, or when one variable decreases, the other variable increases. So if you're looking at that type of a relationship, okay, then we know that the relationship, right, can be represented in this way, okay, that x multiplied by y is equal to k, or we can also write it as, okay, your y is equal to your constant product, okay, divided by x. Right, so in this situation, okay, we already know that the two variables that are given to us there, it's 12 and 7. Okay, so it's going to be 12 multiplied by 7, okay, is equal to, okay, the 4 multiplied by x, because we are told that, okay, these contractors are actually working at the same rate. Okay, so we've got a constant product. Okay, right. So that's why I've basically equated those two together, right? And then from there it becomes easy. All that we need to do is that we just need to solve for x, and then everything else becomes easy peasy lemon squeezy. All right. So you need to ensure that when it comes to these, problem solving situation, try to see, is there an indication, right? Is there something from this word problem that is just telling me that I'm dealing with an indirectly proportional relationship or a directly proportional relationship? Okay, then if you're dealing with a indirectly proportional relationship, then we know that we can obviously use this equation to help me solve for my unknown. Okay, then obviously if it was a directly proportional relationship, right, it is just going to be your y is equal to your proportionality constant multiplied by x. Okay, right. I think there we should be fine. Okay, now let's look at question number 3. I think we covered everything there. Let's look at question number 3. Now, question number 3, nice and easy. We are just dealing with still the number theory, where we just are asked to arrange these values in ascending order. I think everyone should be okay with this. Remember, the biggest negative number is the smallest number, right? So this negative 62, it's the smallest number here, right? Remember, if I'm talking about ascending order, I'm saying from the smallest to the biggest. Okay, so that negative 62 is the smallest number there. Then it's negative 55. Okay, then it's negative 43. Okay, then it's 0. Okay, then it's 8, then it's 25. I always just advise my learners to just cross out values that you've already written so that you don't repeat them and you don't forget to basically write a value down. Okay, nice and easy there, nothing difficult. Okay, now let's look at this question. We are asked to evaluate, okay, this question without the use of a calculator. Now, remember, if they're saying now, okay, without the use of a calculator, please, you can't just punch these, everything in the calculator and just now, regurgitate what the calculator is giving you. You need to basically show how the calculator got to that answer. So in this question, because you can see now it's for 4 marks, it's not for 2 or 1 mark. Okay, we have to show all our steps, taking into consideration the concepts that we already know when it comes to BODMAS. All right, so what is this? I'm just going to start with what I know. Remember, always work numerator, denominator, you're working across. Okay, so the square root of 49 is 7 minus 2 divided by. Then, okay, I'm just going to simplify this part here. You've got, I'm going to just try and zoom it in. Okay, you've got 3 plus, okay, open bracket, negative 2, close bracket, to the power of 3. Now remember, any negative number raised to an odd exponent will always be negative. Okay, any negative number, okay, remember, please take note, any negative number all raised to an odd exponent will always give you a negative number. So what does that mean? If I take negative 2 all raised to the power of 3, that is going to be 3 plus negative 8. Do you see? That number will always be. So it's the same as just saying 2 to the power of 3, okay, which is 8. But because it's a negative number raised to an odd exponent, then the number will always be negative. All right, multiplied by 5. Okay, I just want to simplify that, what the complication there in the denominator. So I'm going to say 7 minus 2 divided by 3 minus, remember, a positive multiplied by a negative, right? We're just dealing with the sides. Positive multiplied by a negative is a negative 8 multiplied by 5. Right, I'm going to continue on this side. Okay, equals. Then obviously, remember, when you're dealing with, fractions, just try to, make the fraction, if there's, terms in the numerator, just make them smaller. Simplify the terms in the numerator, right? So if I say 7 minus 2, I'm getting 5 divided by, right? 3 minus 8 is minus 5. Do you see? Multiplied by 5. Okay, here, obviously, according to BODMAS, okay, all right, I need to first start with the division before I deal with the multiplication. So 5 divided by negative 5 is negative 1 multiplied by 5. Negative 1 multiplied by 5 is minus 5. And we are done. Right, very, very important here, right? The fact that okay, when you take a positive number, multiply by a negative number, I'm going to get what? A negative. Positive multiplied by a negative is a negative, right? Also remembering that you've got like terms in the numerator, terms in the denominator, okay? As you are simplifying, you just want to, as you are working through your solutions, you want to simplify what's happening in the numerator, what's happening in the denominator, and then take it from there. Okay, I think that is the most logical way and the most correct way that you should go about simplifying this question. Now, let's look at question 4. Question 4 deals with your exponential laws, right? Please, when it comes to exponential laws, okay, I'll actually put a video. I'll put a link to a lesson that I've done when it comes to your exponential laws. But remember, if we just do a quick recap when it comes to exponential laws, remember, if I am multiplying powers that have the same base, right? What does the law say? It basically means that if I'm multiplying powers that have the same base, I need to add my exponent. So it's going to be a to the power of m plus a. If I am dividing powers that have the same base, right? What am I supposed to do here? I minus my exponents, a to the power of m minus n. Number 3, right? All right, I just want to deal with if you've got a negative exponent. Now, if I've got a to the power of negative m, right? You see, I've got a negative exponent. Now, if I want to make that exponent positive, right, I'm just going to say it's 1 over, or 1 divided by a to the power of n, right? So that is how I am able to make my exponent positive, right? Also, just want to deal with one more rule. Okay, obviously I haven't gone through all the rules here. I'm just, touching on the ones that we are going to see, or we're going to have to apply as we are going through this question. The power rule. A to the power of m plus 2 all raised to the power of 2. Okay, that basically means that every exponent, okay, that is inside that bracket needs to be multiplied by 2. Okay, so this is the same as saying a to the power of m times 2, which is 2m, plus 2 times 2, which is 4, right? Okay, that is the power rule, right? Okay, so The exponents that are inside the bracket needs to be multiplied by that exponent that is or that exponent that whole term is raised to. Okay, raising a power to a power. Okay, which is the power rule. Right. Okay, so now let's look at this. They say complete the exponential law by filling in the missing parts. We can already see that here the law that is actually the concept that is assessed here. If I already have 1 over a to the power of m, that basically means that this is the same as just saying what? A to the power of negative m, right? Which is that rule number 3 that I've basically highlighted there, right? So that is the same as saying a to the power of negative m. Okay, cool. Now, let's look at question 4.2. Simplify fully. Now, with question 4.2, you have to know your exponential laws to be able to simplify, right, this expression fully. All right, so now let's see which laws are we actually going to use here. Right, you've got p to the power of 4x plus 4. P to the power of, okay, open bracket, negative 2x minus 2, close bracket. Right, I'm going to first remember what I said. Always deal with what's happening in the numerator. See if I can simplify that and make it smaller. Then look at what is happening in the denominator. See if I can simplify that and make it smaller. And then I take it from there. All right, so I'm going to say, all right, remember, I'm multiplying. That dot basically means that I'm saying p to the power of 4x plus 4 multiplied by p to the power of negative 2x minus 2. Okay, I'm multiplying. So which exponential law are we going to use there? Okay, that if you're multiplying, remember, these are powers that have the same base. Okay, what am I supposed to do with my exponents? I'm just supposed to add them. So I'm just going to say p to the power of 4x plus 4 plus, all right, okay, plus, then I'm going to add this, right, negative 2x minus 2. Okay, I'm keeping everything the way that it is, please, right? Then from here, divided by, okay, right, now I'm going to simplify now what's happening in the denominator. Now we can see that when you look at the denominator, we have to now apply what? Okay, the power rule. Right? So with the power rule, what do you know? You're raising a power to a power. So I'm going to multiply that exponent, okay, that is inside your bracket with everything that is happening outside, right? So I'm just going to say p to the power of 2 times x. 2, so same as saying just 2 multiplied by x plus 1. Okay, so I'm just distributing the 2. Right, so it's going to be p to the power of 2x. Do you see? Because 2 times x is 2x. 2 times positive 1 is 2 plus 2. You see? Right, now I'm going to simplify this further. Okay, I want to remove these brackets now. Okay, because they're a bit of a complication. Okay, so I'm going to say p to the power of 4x plus 4. Then remember, I want to distribute this positive. Positive 1. Remember, there's an invisible 1 here, please, guys. Right? It's an invisible 1. Positive 1 times negative 2x is going to give us what? Negative 2x. Positive 1 times negative 2 is going to give me negative 2 divided by, all right, p to the power of 2x plus 2. Right, I'm going to just finish off here. I'm going to simplify what's happening in the numerator. It's going to be p to the power of, right? Obviously here, we have to now add the like terms, but we're now focusing on, you know, our fractions, okay? Right, so 4x minus 2x, right? You'll see that you get 2x. Then positive 4 minus 2 is going to give me what? Positive 2 divided by, okay, then I say p, right? Can I simplify anything there? No. I'm going to leave it as 2x plus 2. Now, what are we left with here? Do you see now? I'm dividing powers that have the same base. Now I'm going to apply that exponential law that talks about if I'm dividing powers that have the same base, what am I going to do with my exponents? I am going to subtract them, right? So that basically means I'm going to say p to the power of 2x minus 2x plus 2 minus. Now look at what I'm doing. Because I want to minus what's happening, right, there in the denominator, please, I need to put that in brackets. Okay, when I say minus, open bracket 2x plus 2, because I'm minusing everything that's happening there in the denominator. Right, okay, then from there I can simplify this further. It's going to be p2x plus 2 minus, okay, remember again, there's an invisible 1 there. Right, so that means that I want to distribute this -1, okay, with everything that's inside my bracket. Right, so it's -1 times 2x is going to give me what? -2x. -1 times +2 is going to give me -2. Right, okay, please don't take these many steps for granted. I know that someone's going to say, but you can, please. Please, don't. Right? Okay, right. This is honestly for my learners. Okay. Oh, also, if you're one of my learners, right? Okay, please comment with a smartie.
What you talking about?
Actually, you can't comment with a smartie. Please comment with like a sweet or something. Okay. Let's see how many of my learners are actually watching this lesson. All right, and then from here we can just simplify positive 2x minus 2x. Remember, I'm just collecting like terms. That is going to give me 0. Then positive 2 minus 2 is going to give me 0. But remember, I can't just say p and then leave it like that. It's p to the power of 0, because when I minus everything together, I got 0. All right, then from there, anything to the power of 0 is equal to 1. Okay, and that is basically our final answer. All right, so please make sure when it comes to, these simplification questions, please, okay, show all your workings. Okay, and also don't take for granted, okay, just showing these little steps so that you don't make any unnecessary mistakes, because I know that learners are prone to making a mistake, okay, especially if you don't put that bracket there. Okay, some learners will just say minus 2x plus 2. Okay, so it's very important that you put that bracket there so that you take into consideration that you are subtracting everything that's there in the denominator. Okay, so just get into the habit of, just putting those brackets there, because when you put a bracket, then you'll remember that I need to now distribute whatever sign I have in the front of my bracket with whatever is happening inside my bracket. All right, and then we're done with question number 4. All right, let's look at question number 5. Right, so with question number 5 deals with your patterns. All right, we are given so we are basically given a geometric pattern here. Remember, if you're talking about a geometric pattern, we are basically talking about, like a pattern that has been represented using your diagrams. Okay, right, so that's basically what's given to us there. Right, so they say that a friend created a pattern using squares. In the first arrangement, she used 2 squares. Okay, they're saying in the first arrangement there were 2 squares. In the second, she used 5 squares. In the third, she used 8. Right, so I mean, you can count to just verify that, but they've already given us how many squares are given in the first, second, and in the third arrangement, so you don't have to really worry about that. Now they're saying study the pattern carefully and extend it by drawing a sketch, okay, showing how the squares will be arranged in the 6th pattern. All right, so here obviously here it's just you getting a feel of how they are adding these squares. Okay, because you can see that if they added, this is the first, these are the two squares. We had two. Okay, then from there, I think the tip that I can give you is first check to see, okay, am I given a linear pattern with a constant difference, or am I given a pattern that has a constant ratio? Right? So that's basically what you need to ask yourself first before you try to figure out what's happening in your fourth arrangement. Okay, so you'll see that now, as it basically, if you were to now, it's 2, it's 5, it's 8, right? You'll see that now, as we move from 2 to 5, they've added 3. From 5 to 8, they've added 3. So we can say we just have a linear pattern here, right? Where we just have a constant difference of 3. So they're adding 3 all the time. So that means that now when it comes to the fourth arrangement, right, I have to just add 3 squares to the 8 squares. So now it's a matter of now, how am I supposed to add those squares? Right, so you can see that with the first one, okay, it's just 2, ne? But now with the second one, remember, we're adding 3 all the time. Remember, I plus 3. Okay, let's just do this. Remember, I'm plusing 3. And then I'm plusing 3, basically. Right, I hope you get what I'm doing there. Right, so from here, okay, this is the first one. Now, if I want to look at the second one, remember, I still have those 2 that were like that. But now, I want to add 3. Okay, but now when you're adding, do you see that they're adding these 3s in a way that balances, right, the arrangement? Okay, same as I'm going to add 1 here. Okay, I'm going to add in a different color. I'm adding 1, I'm adding 2, I'm adding 3. Do you see that it balances nicely, right? Now, let's look at the third arrangement. Okay, now remember, for the third arrangement, I already have, right, 1, 2, 3, 4, 5. Okay, I'm going to just put the 5. So it's the 1, 2, then a 3, 4, 5. But remember, I basically want to add 3, but I want to now make it balance properly. Okay, right. So from here, let's look. Okay, so I'm going to add 1. Do you see? 2. Do you see? And then 3. Do you see it balances? These are the ones that I'm adding. Do you see? I'm balancing as I go. Right. Okay, I'm balancing as I go. Now let's look at the fourth one. Okay, let's look at the fourth arrangement. Okay, remember, I already have 1, 2, 3, 4. 1, 2, 3, 4. Right, so 1, 2, 3, 4, 5, 6, 7, 8. And then from here, I want to add 3. Right, so remember, I want to add 3 in a way that balances. All right, so I'm going to add 1. Do you see? 2. And do you see? 3. Do you see? That is basically what I have added there. So therefore, this is what I want. Okay, this is how I'm going to get, okay, my pattern. Okay, for the fourth arrangement. Obviously, we need to continue because I think the question is asking us to study the pattern carefully and extend it by drawing a sketch showing how the squares will be arranged in the sixth pattern. Okay, so I need to continue. Right, I'm just going to show you how we keep going. Right, and then I'm going to say this is the fifth. Okay, right, so we've got 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Okay, remember I'm adding 3. So I'm going to say 1, 2, 3. Do you see? Right, that's the fifth one. Then I'm going to continue. Remember, I want to go to the sixth pattern. Right, then the sixth pattern. I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, please be neat. Okay, then I want to add 3. So I'm going to say 1, 2, 3. Do you see? That is what I have added. Right, so this one will be my 6th pattern. Right, so this is actually the answer that they're looking for, not the 4th one, but the 6th arrangement there. Okay, it needs to look something like that. All right, cool. Okay, taking into consideration, do you see I've just added 3, 3, 3, 3, 3 all the time, right? Nice and easy. So here, right, with these types of questions, you just need to look at, the pattern that is given to you, and then from there, identify how you can add, obviously, right, the additional squares or sticks, okay, to balance out the pattern, right? So that it looks, okay, it's growing in a manner that makes sense. Okay, now use the table below to determine an algebraic formula relating to the number of squares to the pattern number. Do you see here now, when they say Tn is equals to, right, they're actually asking you for the rule. All right, okay, so now you can see that here, right, remember this question is for, right, this geometric pattern. Right, remember geometric, just a pattern that is just shown to us using diagrams. Okay, so we are still talking about this pattern here. They're telling us that the number, okay, the pattern number, for pattern number 1 you've got 2 squares, pattern number 2 you've got 5 squares, pattern number 3 you've got 8 squares. Now they want you to determine the rule for this pattern. Remember what I said when we started the lesson, when we were looking at the first question, where they were asking us to, determine the equation that represents the relationship between x and y, right? I said that, remember, and you're looking at patterns. Remember, we already said that here, as you just keep adding 3, adding 3, adding 3, right? So if we're constantly just adding the same amount, that tells us that we're dealing with a pattern that has a constant difference. So if you're dealing with a pattern with a constant difference, what did I say? You start with the standard formula that Tn is equal to the constant difference multiplied by the pattern or the position, right? Can be position 1, or the term 1 is in position 1, term 2, position 2, term 3, okay, right? Plus C. This is the standard formula that we use. Now in this case, we already know that what the constant difference is in this case. Remember, I already explained this. The constant difference here is 3 multiplied by n plus c is equal to Tn. Remember, this Tn basically means how many squares do we have, right? So Tn basically talks about what is the value of the term. So if I'm looking at term number 1, term number 2, term number 3, okay, and I say my term number 1 is 3, term number 2, 3, 6, term number 3, 9, right? Term number 1, the position, which is the n, is 1. Remember, this is Tn. The subscript there is 1. All right, okay, but now if you're looking at that whole number, this whole number, that is Tn. All right, so n just gives us the position. I'm in position 1, or term number 1, all right, or pattern number 1, all right, okay, right. And then if I'm talking about Tn, I'm saying what is the value of term number 1. Do you get what I'm saying? Right, so we start with this standard formula. Tn is equal to 3n plus c, right? Then remember, if I want to determine what is the value of my c, that's it. Okay, once I have my value of the c, or the constant, okay, then I'll be able to then obviously have what the formula is, right? So then I'm just going to focus on pattern number 1, okay? So pattern 1 has how many squares? Remember, here I was just doing an additional example. Please let's not be confused. Pattern 1, okay, has how many squares? 2. So how many squares? It's 2 is equal to, I'm just focusing on this row, please, okay, to help me. I'm using this row to help me find my constant. Then it's going to be 3. What is n? It's 1 plus c. Right, and then from here, all that I need to do, right, I just need to solve for my c. So it's going to be 2 is equal to 3 times 1 is 3 plus C. So it's going to be 2, okay, minus 3 is equal to C. 2 minus 3 is minus 1 is equal to C. Therefore, you can even check with this second row. If your Tn is equal to 5, if Tn 5 is equal to 3 times 2 plus C, you'll still see that your C, okay, the constant, is equal to negative 1. Therefore, the rule Tn is equal to, okay, 3, okay, because it's a constant difference, it doesn't change, multiplied by n minus 1, right? So this is the rule, all right, for this pattern. Okay, and remember, once you have the rule for a pattern, then even if they ask you, for number 20, how many squares will we have? You'll be able to, calculate that fast. Okay, so our rules just help us, calculate the value or how many squares or what will be the value of our pattern when when I'm in position number 30, position number 100, 1,000, and so on and so forth. Right, cool. Now let's look at question number 5.1.3. Now if you look at question 5.1.3, now they say, now we need to use the formula that we've obtained in question 5.2 to determine the pattern number if there are 101 squares. Remember, the formula that we got, okay, was that Tn, right, is equal to 3n minus 1. Okay, that is the formula of or the rule for this pattern. Okay, now they are telling us that if you have 101 squares, okay, so this value that's given to us, 101 is Tn. You see, if our Tn is 101, what is the pattern number? What is the position? Okay, n. Right, we are trying to solve for n. What is the pattern number? Okay, what is the position? Okay, right, that's basically what they want. Right, so I'm just going to substitute here. Honestly speaking, if you can't solve equations, you're going to struggle. That is why, okay, when it comes to, everything else, it starts from being able to solve equations. If you can't solve equations, it's going to trap you. All right, so it's 101 is equal to 3n minus 1. I think here we should be fine. Solving for n, so it's 101. Okay, I'm going to plus 1 because it's going to the other side is equal to 3n. So it's going to be 102 is equal to 3n. I'm going to divide by 3, divide by 3. Therefore, the pattern number is equal to 34. All right, and we are done. Right, if you look at question 5.2, okay, we are given that y is equal to 8x minus 3, and they're saying x is an element of -2, -1, 0, 1, and 2. So basically what they've given us here, they've actually given us, right, the input values, right? Right, they say x is an element of, right? They've given us the x values. Remember, x values are the, our input values, all right? So they've given us the input values. So now, if they're asking us now, if you look at this question, they say, fill in the input values and the rule in the flow diagram below and hence determine the corresponding output values. So with this, we actually want to fill in what is the rule, what is the input values, and hence what are the output values. All right, so we already know that the input value, its first one is -2, next one -1, 0, 1, and 2. Now they've given us, this is the rule, y is equal to, right? Because this rule is telling us how we are going to get what? The y values, the output values. Okay, remember, input values x, okay, output values y. Okay, right, so I'm just going to say therefore y, okay, or I can even say 8x minus 3 is going to give me the y. Okay, I've just swapped, okay, the values around, but it's still the same thing. Right, now what do we need to do here? All that we need to do here is that we're gonna, if you substitute, okay, where you see an x, you're gonna put a -2. That is going to help us get our y. So what are we gonna do? I'm just gonna do the first one with you. So if I say 8, open bracket, -2 minus 3, that is going to give me my first output value. All right, so 8 minus 2, it's minus 16 minus 3 is equal to y. Okay, so minus 19 is equal to y. So the first y value, or the output value, is -19. Using the same concept, we're just going to substitute -1. Okay, you're going to get -11, -3, 5, and 13. Okay, most learners usually get this question correct. Okay, and we are basically done with question 5.2. Right, now let's look at question 6.1. So question 6.1, you can see that here we are given an algebraic expression, right? Why are we calling it an expression? Because we don't have an equal sign there. We can't call it an equation, okay, because we don't have an equal sign. So now, when it comes to your algebraic expressions, okay, right, guys, you need to be able to, understand what makes a term. Right. Okay. So you need to remember, yes, your terms are, separated by our signs. Okay. Right. But you need to understand that now the sign that is in front of a number, okay, that sign is for that number. Right. If you get what I'm saying. So for example, if I want to determine how many terms I have here, this is going to be my first term, 2x to the power of 3y. Then this is going to be my second term, positive 3x y to the power of 3. And then this is going to be my third term, okay, right? Then this is going to be my third term, positive 5x squared. So the term, right, it goes with that sign. Obviously here, I mean, we don't have a sign there, but we already know it's an invisible positive. It's a positive 2x to the power of 3y. Okay, cool. Now let's talk about what is the coefficient of x. Now, if you're looking at now this expression and you want to determine what is the coefficient of x, guys, please don't go into these questions thinking if they ask you what is a coefficient of a particular term, then you think what is the number that is in front of x. No, wrong. Okay, they're not asking you. The coefficient of a term is not saying go to the number that comes in front. Right? Okay, right. So if you were to say now, okay, the term that contains your positive x, right? Remember, this is the term that contains your x. I mean, right? It's your positive 3x y to the power of 3. Okay, so I'm going to look at 3x y to the power of 3. And the question is asking me, what is the coefficient of x? Okay, so you can't say the coefficient of x is 3. That will be incorrect. They're just saying, what must I multiply x with, okay, to get this whole entire term? All right, so basically what I do here is that I just tell my students, if they're asking us what is the coefficient of x, just cross out that x, and then you can see that, oh, okay, the coefficient of x is going to be 3y to the power of 3, because if I take 3y to the power of 3 and I multiply it with x, I will get back to that original term of 3x y to the power of 3. All right, so that is how you need to think about that question. If they're asking you what is the coefficient of a particular variable, right, is that you need to ask yourself, what must I multiply that variable with to get the original term? Okay, right, even if I say 3x squared y squared z to the power of 3, and I say to you, what is the coefficient of y squared? Right, so I'm asking, what must I multiply y squared with? Okay, obviously, if you're focusing on this term, to get the original term. So I'm going to have to multiply it with 3x squared z to the power of 3. So that is the coefficient of y squared. All right. Okay. Very, very important. Right. So now from here, what is the coefficient of x? All right. You'll just say that your answer here, it's 3 y to the power of 3. Okay, also even if, let's say for example, this term was negative 3xy to the power of 3, right? Negative 3xy to the power of 3. Then they said, what is the coefficient of x? Right? Remember, you cross out the x, it would be negative 3y to the power of 3. All right, so please be aware of that. But in this case, it's a positive. Write the expression in descending powers of x. Right, so they just say you're going to be looking at the exponents where you've got your base x, okay, and then you want to write it in, decreasing exponents, okay, from the highest to the lowest. So I'm just going to highlight where I've got the x, okay. Do you see the base x, right? So it's x to the power of 3, right? And then you've got okay, let me just make it smaller. Then you've got, okay, then you've got x, then you've got x to the power of 2. All right, so if I want to write this in descending powers, descending is going down, right? I'm just going to say, remember, I'm starting with the biggest one. I'm going to say 2, remember, x to the power of 3, y. Then I'm going again, right? Then it's x to the power of 2. Do you see? After x to the power of 3 is going to be x to the power of 2, ne? So I'm going to say plus 5x to the power of 2. Do you see? Plus, okay, remember, 3x y to the power of 3. Do you see? I've wrote it in descending powers of x because this is x to the power of 3, x to the power of 2, and remember, this is x to the power of 1. There's an invisible 1 there. I've written my answer in descending powers, or I've written this expression in descending powers of x. Right, and we are done. Now let's look at question 6.2. Still, we are given an expression here, and they're asking us to simplify it fully. All right, so here, please don't make the mistake now of thinking that you need to apply the power rule. Okay, we can't do that, right? Because why? We've got a plus there in between. If it was just xy to the power of 2, then we would just say x to the power of 2, y to the power of 2, die. But in this case, because, right, the terms that are inside the bracket are separated by a plus, even if it was separated by a minus, right, we would need to now obviously apply not the power rule, okay, but we have to first expand this bracket, okay, and then use the FOIL method to simplify. Right, okay, cool. So I'm going to now expand this bracket. This basically means that I've got x plus y. Okay, I've just expanded my bracket. All right, then there's two ways you can do that. Okay, do this. You can either say, use the FOIL, right? So x multiplied by x. So you want to distribute the terms that are in the first bracket with the terms that are in the second bracket. So I'm going to say x times x. This gives me x squared. Blah. Okay, then I'm going to say x times positive y is going to be xy. Then I'm going to say y times x is positive xy. Then y times y is positive y squared. Right? And then if I simplify that further, you can see that I've got your like terms here, xy and xy. Right? Therefore, your final answer is going to be x squared plus 2xy plus y squared. All right, that is your final answer. Alternatively, if you want to use this method, okay, I'm just going to give you an OR, right? You've got x plus y, all right, all squared. You can just say same thing, x plus y. You write it out twice, please. Okay, and then remember, when I distribute this x with what's happening in the second bracket. So I just say x multiplied by x plus y. Do you see? Then I want to distribute this positive y with what's happening in the bracket as well. So I'm going to say positive y multiplied by x plus y. Right. Then from there, I can say still x times x is going to give me x squared. X times y is going to give me positive xy. Then y times x is going to give me xy. Y times y is going to give me positive y squared. Then I'm going to add my like terms here. It's going to be x squared plus 2xy plus y squared. Okay, and that is my final answer. So here, where it just depends on, what you prefer, but both methods would be correct. Right, now let's look at question 6.2.2. So here we are simplifying, right? But now let's look at this very carefully, right? If you look at now what's happening here, if you're just looking at it from a surface level basis, okay, you won't be able to simplify this. Now, when it comes to this part, we first need to, for us to even start with, the simplification part, okay, you need to remember the concepts that we've learned from, how you factorize your difference of two squares, how you factorize your trinomials, right, to help you in simplifying this expression, right? So now let's start off here. Remember, when we're factorizing, you want to see, okay, do I have a highest common factor, right, in the numerator? We can see that in the numerator, okay, it looks like the highest common factor there is x. So if I take out my x, what am I left with? Okay, x to the power of 3 divided by the number that I've taken, the variable that I've taken out, is going to give me x squared. X to the power of 2 divided by, or positive x to the power of 2 divided by x is going to give me positive x. Then negative 2x divided by x is going to give me negative 2. Okay, so I've basically, taken out, common factor, which is x, and then that is what I'm left with in the numerator. Now let's look at the denominator. You can see that in the denominator, we definitely have a difference of two squares. Remember what, I've told you when it comes to checking to see if you've got a difference of two squares, like if you've got like an x squared minus 16. If you take the square root of 16, you're going to get a perfect square. Remember, I'm just focusing on the 16. If I take the square root of x squared, I'm going to get a perfect square, right, which is x, right? So, or even if I've got x, or maybe I can say y squared minus 25. The minute you've got a something squared minus something, then that should tell you I've got a difference of two squares, right? So now you can definitely check now if you've got a difference of two squares by now just squaring, right, that value there, right? And if you get a perfect square, then you've got a difference of two squares. Now remember, how do we factorize your difference of two squares? Open two brackets, all right? It's going to be x, it's going to be x, all right? Remember, it's a plus and a minus, all right? Then obviously the square root of 1 is 1. So it's 1 and 1, right? But now, do you see that? We're like, but we're still not getting anywhere, right? Because now, I still have, that trinomial there, the top, right? That is kind of making my life a bit hard. Now, you need to think back to, what we learned when it comes to factorizing your trinomials. Okay, so please just listen to the steps, how I factorize that. So I've got x now. Remember, when I want to factorize, I just want to factorize. I'm going to just go down a bit just so I give you a proper in-depth explanation of how we need to factorize it. So if you've got x squared, right, if you've got x squared plus x minus 2, right? I've got this trinomial here, right? And I want to factorize this trinomial. Remember what I said, and this I'm just now speaking to my students, right? But obviously, if you also it's the first time being taught by me, just try to listen. All right, okay. If you're factorizing, you want to look at what are the factors of 2? Right? Okay. Right now, the factors of 2, it's just 1 and 2. Right. So if I want to factorize this trinomial, I'm just going to open 2 brackets. Okay. And I say x and x because x times x will give me x squared. Now, what I said that now, you first open 2 brackets, then you put, deal with that first term there. Obviously, it's going to be x and x. Now, we want to deal with the signs. You always just look at the last sign there, right? Okay, the sign for the last term. So, when that sign is a negative, okay, so let's just say when the sign for the last term, right, okay, is a negative, okay, that means that in our brackets, we need to have a positive and a negative, because a positive times a negative will give me a negative. If the sign for the last term is a positive, okay, now you need to be careful when it comes to it being a positive. It depends. If all the signs in your expression are positive, okay, if the sign for the last term is positive and all signs are positive, okay, then you'll just have a positive and a positive. Okay, and then if your sign, right, for the last term, right, is positive, okay, but the middle term is negative, okay, then you need to remember that the highest factor takes sign of middle term. Okay, right. So I don't want to go into a lesson when it comes to this, right? So the highest factor will take the sign of the middle term. But you let me know if you would like for me to go through how we factorize trinomials, and I give you those different scenarios that you can be given so that you know how to factorize given those different situations. Just tell me below if you'd like for me to do that, okay, and then I'll also do a lesson on that, but I don't want to go deep into that. So in this case, because we can see that our sign here is negative, okay, our sign is a negative, so that already tells us that obviously our signs in our brackets, they need to be a positive and a negative. Right, and then also same thing here. Even though our sign is a negative, right? Sign is a negative, right? And you've put a positive and a negative. It's still the same concept still applies. That when it comes to now determining, right, from these factors, remember these are just the factors of 2. Okay, to determine which factor needs to go in the first bracket, just tell yourself, okay, the highest factor always takes the sign of the middle term. And also, when you're trying to now, when you're obviously looking at, looking at the factors for your last term, when you're trying to factorize your trinomial, right, you always now need to check with the factors, because with this one we just had 2 factors, but in some situations you can get 4 factors or 6 factors, whatever. So you need to identify the factors that you should you need to identify factors that will get you to a positive 1, right? So in this case, 2 and 1 can get me to 1. All right, so first thing here, open up your brackets, you put an x and an x. Because your sign is negative there, you have to have a positive and a negative in your brackets, because a positive times a negative will give me a negative. And then because you've got a 2, right, the factors of 2 is 1 and 2, and I've mentioned that the highest factor takes the sign of your middle term. What's the highest factor here? The highest factor here is 2. So what's the sign of my middle term? The sign of my middle term is a positive, so the 2 goes there and the 1 goes there. Then from there I factorize, and you can also always just check your answer. Negative 2 times negative 1 gives us negative 2. Positive 2 times negative 1, sorry, it gives us negative 2. Then positive 2 minus 1 gives us positive 1. Right, so you see that we've actually factorized this trinomial property. Right, so now going back to there, remember I've shown you how we need to factorize that. I'm just going to open my bracket. It's x plus 2, okay, x plus x minus 1, okay, divided by x plus 1, okay, x minus 1. Right, then from here, what are you noticing now? Because you just multiply it, do you see? We can actually cancel out certain terms. So you can cancel out this term, you can cancel out that term, right? So then from here, you can see that you actually, this value simplified is going to be x plus 2 divided by x plus 1. All right. Okay, and that is our final answer. Okay, and we are done. Now let's look at question 7. Question 7 it deals with the concepts that we've learned when we were looking at how you draw your linear graph or your straight line. Okay, remembering the fact that when you're working with a straight line, okay, there's a standard form, okay, for a straight line. Okay, the standard form of your straight line is given in the form of y is equal to mx plus c. Remember, a standard form of a straight line, y is equal to mx plus c. Okay, where we've mentioned that the m, okay, the coefficient of the x is your gradient, okay, and the constant, please take note of what I'm doing as I'm highlighting there, right? That is your y-intercept. Okay, so this is just the standard form of your linear graph. It's always given in this form. All right, then if you want to draw your linear graph, we've already mentioned that when you're drawing a linear graph, you can either, maybe if the question is not really specific as to which method you should use, you can use the dual intercept method, you can use the table method, right? But most of the time, if you're given an equation, it's mostly faster to use the dual intercept method when you want to draw your linear function. All right, but let's not go deeper into that. All right, so please make sure, if you want to see more lessons as you are going to be going into grade 10 and you want these full in-depth lessons, please make sure that you are subscribed to the channel. So it says identify the values representing the gradient and the y-intercept from the equation. Right, so do you see they've given us this standard form of our linear function. And you see that it's in the form of y is equal to mx plus c, right? Okay, can you identify the value that's in the place of the m? You can see that it's the 2, right? So the gradient, okay, so the gradient is 2, okay, and then our y-intercept. Let's look, the y-intercept, look at what I'm doing. It's the negative 5, because what I said, the sign is attached to that number, okay, that comes after it, right? So the y-intercept is negative 5. Nice and easy. Now they're saying given the 3y plus 2x is equal to negative 6, right? They've basically given us this. Now they ask us to calculate the x-intercept. Now remember, if I just quickly give you a recap of what is the x-intercept, what is the y-intercept. If I'm giving you a linear function here, this is my linear function, Cartesian plane, and on my Cartesian plane, I've got a function, linear function, a linear graph, right? This linear graph is cutting the x-axis, and it is also cutting the y-axis, right? So where is this linear graph or straight graph cutting the x-axis? It's cutting the x-axis there, right? We call this what? The x-intercept. Okay, this linear function is also cutting the y-axis, or the y-axis way. Here, we call this part the y-intercept. Now, you need to remember, what happens at the x-intercept? What happens at the y-intercept? At the x-intercept, if this is my origin, right, do we all agree that at the x-intercept, the y will be 0? So yes, we'll have an x coordinate there, but the y will be 0. So if I want to find my x-intercept, I can just let y equal to 0. Okay, now what happens at the y-intercept? Now at the y-intercept, the x is 0. Do you see? It's going to be 0, but the y will be a particular value. So if I want to find the y-intercept, I just need to let my x equal to 0. There, I've shown you why. Right, so now same concept here. If they want you to calculate the x-intercept, the point where the graph is going to cut the x-axis, what must I do? I just need to let y equal to 0. So I don't really have to stress much about, putting the formula in standard form and then, just wasting time because it's just for 2 marks. Okay, so from here, if I let my y equal to 0, that basically means where I see a y, I just substitute 0. Right, so it's going to be 0 plus 2x is equal to -6. All right, I'm just going to do it here. I'm going to continue. 3 times 0 is 0. So I'm going to be left with 2x is equal to -6. How do I solve for x? How do I isolate the x? I'm going to do the inverse. It's 2 times x. To get rid of the 2, I'm going to divide by 2. Divide by 2. So x is equal to 2, 4, 6, -3. So that basically means that when my y, if you're looking at just this linear function, which it is, okay, when my y is equal to 0, my x is going to be equal to -3. Right, now they say sketch the graph of 3y plus 2x, which is equal to -6 on the set of axes provided below. So, when you want to draw these linear graphs, right, the tip I can give is that always just have your graph, your equation in standard form, okay? Or if you don't really want to waste time there, because actually they didn't really ask us to, put this equation in standard form, right? And we just required to just draw, this linear function, right? So what we can basically do there, right? Remember, if you're asked to draw your linear function, you can either use the dual intercept method or you can use a table method, right? Okay, and for me, I feel like the dual intercept method is just the fastest method that we can use to help us draw our linear function, okay? Because we just find these 2 points, okay, that the graph is cutting the x and y axis, then we connect those points, then we're done, right? We don't want to be taking too much of time. It's out of 3 marks, right? So we want to be fast. We want to be, get it over and done with very quickly. So if they give us, the equation of this graph, and they're telling us that 3y plus 2x is equal to -6, right? And we already found the x-intercept. Remember, we found that when your x is equal to -3, your y is 0. Okay, remember, we found the x-intercept by letting y equal to 0, right? X is -3, y is 0. So all that I need to do, I just need to find what? The y-intercept. Right, so for me to find the y-intercept, what do? I'm going to let x equal to 0. All right, so if I let x equal to 0, please, I'm still using the same equation. It's going to be 3y plus 2. When I see x, I'm putting a 0, is equal to -6. Right, so 3y, this is plus 0, is equal to -6. All right, then I'm going to divide by 3, divide by 3. Y is equal to -2. So if my x is equal to 0, my y is -2. So I've actually found 2 points. Okay, I've found the x-intercept, I've found the y-intercept. Okay, the points where this graph cuts the x-axis as well as the y-axis. Right, I found that. Okay, so all that I need to do now, I just want to plot these points on my Cartesian plane. All right, so if x is -3, y is 0. So x is -3, y is 0. Remember, when you're drawing, you always start, when you're plotting your points, start from the horizontal axes and then you connect. So x is 0. Okay, so x horizontal, y, next is x is -3, y is 0. It's there. Okay, that's my point. -3, 0. The other one, if x is 0, y is -2. Same. Start from the horizontal, you go down. X is 0, y is -2. X is 0, y is -2. Right. Then from there, we just connect our points. Using a ruler, please. Let me just connect it properly. All right. And then remember, when you're drawing this goes all the way up to, negative infinity and positive infinity. So we put those arrows there to show that obviously this line, it's not a segment. Okay, it's just a line that goes all the way to positive infinity, all the way to negative infinity. It doesn't end there. So if you don't put the arrows there, then you're saying that the line terminates there and it terminates there, which is not the case. All right, all done with question 7.2. Now, let's look at question 7.3. Right, with question 7.3, they've given us these points. And they're actually telling us now that these points, remember, when you're working with maths, you always need to think of something practically. Okay, they're telling us now these points are points on a straight line. So if I were to now think, try to envision this scenario, I'm given these points, and these points are like points on a straight line, basically. So there are points on the same line, right? Use the points to determine the equation of a line. Right, so now we're trying to determine what would be the equation of this line that has these points on this line. Remember, if you want to actually determine the equation of a straight line, we use which formula? Y is equal to mx plus c. Works every time. Right, so the first thing that we want to determine, right, we want to determine what is the gradient of this line. Okay, you can just identify any 2 points. All right, remember, when you're trying to calculate the gradient is equal to y2 minus y1 divided by x2 minus x1. That is the formula that we use to calculate the gradient of a line. Then I always tell this to my students, just label your points. I can call this point 1, I can call this point 2, right? You can even call this point 1 and point 2, you still get to the same answer. All right, then what do? What is my y2? Obviously, this is going to be my y2, which is a half. Minus, what is my y1? Obviously, this is going to be my y1, which is 1. Divided by, what is my x2? This is my x2, -2. Minus, what is my x1? This is my x1, -2/3. You see, look, minus, do you see open bracket, -2/3. Please, if you don't put those brackets there, okay, you gotta make it, it's minus -2/3. Don't make that mistake, please. All right, then from here, okay, all that I need to do, I'm just gonna punch it into my calculator the way that it is. Don't want to be spending time, so it's going to be a half minus 1. Okay, a half minus. So honestly speaking, this is the same as saying, let me actually discuss this. This is the same as saying 1/2 minus 1 divided by -2, and negative times a negative is a positive 2/3. So that's basically the same thing there. Okay, then you'll see that the gradient, okay, for this line is 3/8. Okay, that is our m. But remember, okay, we've just found m. We still need to find c for us to be able, to have the full equation of this line graph. But then do you see that for c, it's actually very easy. Okay, there's 2 ways that you can see, calculate c. Do you see that this c, the other point on the graph, is actually the y-intercept? You see, it's actually the y-intercept. right? So we know that if you are given the y-intercept, that y-intercept is C. So it's just a coincidence that they said it's C and it's C. Do you know what I'm saying? Right? But the y-intercept, because the x is 0, right? Then that means that that is the y-intercept. Therefore, y is equal to your m, which is 3 over 8x, right? Then you see that the y-intercept there is 3, positive 3, right? And this is the equation of our graph. If you didn't see it like that, another way that you can do it, you can just say y is equal to 3 over 8x plus c. Then you would just substitute that other point that's given to us. Do you see that there was another point there? Okay, remember we use those 2 points to calculate the gradient. Then the other point, we can just use it in this same equation to find out what is c. Okay, so where you see a y, what am I going to put? I'm going to put a 3. Do you see this is y, this is x, this is y. Remember, when you are, writing out your points, they are in that order of x and y, right? Which is equal to 3 over 8. What is my x? It's 0 plus c. Okay, so do you see still, this cancels, so it's 0 and doesn't cancel, it becomes 0 plus c is equal to 3. Therefore, 3 is equal to c. Okay, so in case maybe you didn't see it like that, you can also see it like that. Okay, right, great stuff. Now, almost there. Let's have a look at question 8, right? With question 8, we are dealing with exponents. Remember, when it comes to solving exponential equations, all right, for you to be able, if they give you 3 to the power of 2 is equal to 3x, right? Remember what we know. When the bases are the same, right? Obviously, when you are, solving exponential equations, right? And you've got a variable in the exponent, right? If the variable is in the exponent, okay, that tells you that you're dealing with exponential equations. And if you want to be able to, in this situation, solve for x, you need to just remember that, okay, because I'm given exponents, right? Exponential equations, that means that before I can do anything, my bases always need to be the same, right? So in this case, because our bases are the same, then I can equate the exponents. So therefore, it's just 2 is equal to x, right? So therefore, x is equal to 2. So you need to always also remember that, think of that when you're going through your, revision for your paper 1. Are you able to solve your exponential equations? All right, okay, I'm just going to focus on the ones that are given to us here so that you don't go a bit too much over time. Now, what is the value of a? Same here. Do you see, right? Given an exponential equation where they're saying 5a is equal to 5 to the power of 2. So what is a? Because the bases are the same, we can see that then a is equal to 2. When the bases are the same, you equate your exponents, and then that is that. Number 8.2.1, right? So here we are asked to solve for y. And, what I was actually even telling my students, when you're given an algebraic equation, right, where you've got denominators, right? We know, even when you're dealing with fractions, you always want to find the lowest common denominator, right? But remember, if you were looking at fractions and I gave you 1 over 2 plus 1 over 4, and then I say, what is this? What is 1 over 2 plus 1 over 4 equal to? The first thing that you would do in grade 7 is that you would want to find the lowest common multiple. That's what we called it, right? Okay, once our denominator, because you have to have your denominators the same for you to be able to now add these two fractions. All right, so you find the lowest common denominator, which is 4. Then you'd multiply by the lowest common denominator, and then so you multiply by 2, and then it'll be 2 over 4 plus 1 over 4. Then you'll be able to add, and then you'll get 3 over 4. Right, that's the concept. But now, when we're dealing with algebraic equations, right? And now in this situation, we won't call it lowest common multiples anymore because we've got a variable in this situation, right? So if I want to now add all of these terms together, I need to find what is my lowest common denominator. All right, so you can see that here, what will the lowest common denominator be? Because you see that it's negative 8 divided by 1. Positive 2 divided by 1, which is equal to negative 6 divided by 1. Right? So you first need to identify what will the lowest common denominator be. Once you find the lowest common denominator, then you multiply all the terms by that lowest LCD. Alright, so in this case, we already know that the lowest common denominator here is y. Do you see? Because all the terms have to have that denominator of y for me to be able to add them together. Alright, so I'm going to multiply every single term by that lowest common denominator. Right? So I'm going to multiply this negative 8 over y by y. That positive 2y by y. Negative 6 by y. Right? And then also here, what does this mean? Okay, y cannot be equal to 0. Remember, because I'm dividing by y, okay, the y cannot be equal to 0, because if my y is equal to 0, what will happen if I say negative 8 divided by 0? It's undefined. Right, so that is why they've basically put that there, okay, to let you know that y cannot be equal to 0, because the minute your y is equal to 0, then it's undefined. Okay, the whole equation does not exist, basically, is undefined. All right, so here, if I take y multiplied by, remember, if I say negative 8 divided by y, and I say multiply by y, do you see that the y's are cancelling, right? Okay, so I've got negative 8. There, I say positive 2y times y. I've got positive 2y squared, which is equal to negative 6 times y. I've got negative 6y. Right, so sorry, I think I put too many equals. Then from there, do you see, it becomes now a simple equation that we can solve for y. Always, what I always do, just move all of the terms to one side, right? So I'm going to say, I'm just going to put them in proper order. So I'm going to say positive 2y squared, right? And then negative 6y, it's going to jump. Now it's going to go to the left-hand side. It's going to be positive 6y. Then you see that this negative 8 is already still on the left. So it's going to be negative 8, which is equal to, do you see, 0? I've got nothing left on the right-hand side. Now, do you see it now? This is going back to that concept of what? Factorizing our trinomials. Remember, if you're factorizing our trinomial, right, and you've got, a coefficient for either your x squared, y squared, or whatever variable squared, right, that is greater than 1, we first want to make that coefficient 1. So how? I'm going to just take out that 2. Okay, what am I going to be left with? 2y squared divided by 2 is y squared. Positive 6y divided by 2 is positive 3y. Negative 8 divided by 2, negative 4 is equal to 0. All right, then you'll see if I divide by 2, I can divide by 2. Do you see that the 2 cancels? Right, so I'm left with y squared plus 3y minus 4 is equal to 0 divided by 2 is not undefined. It's 0. Then from here, right, then I want to now factorize. Do you see this trinomial? Remember now, when you're factorizing trinomial, what did I say? You open 2 brackets. Okay, then you want to get a y squared. So it's going to be a y and a y. Right, then you look at the term, the sign of the last term. It's a negative. If it's a negative, that means that we want to have a positive and a negative in both my brackets, because a positive times a negative will give me a negative. Then I said we're going to look for the factors of 4. What are the factors of 4? It's 1, it's 2, it's 4. These are numbers that can go into 4 without leaving a remainder. Factors. Numbers that can go into a number without leaving a remainder. Then from there, we want to identify, okay, from these factors, which combo is going to give us, or which combo can get us to 3. Okay, definitely the 1 and the 4. Okay, or yeah, definitely the 1 and the 4. right? Because if I say 4 times 1, I can get to 4. And then if I say 4 minus 1, I can get to 3. You know what I'm saying? Then what did I say there? Okay, after you've identified the combo that you're going to be using, then I said the highest factor takes the sign of the middle term. So what's the highest factor here? It's 4. What's the sign of the middle term? Positive. So then it's 4, and that is 1. Then you can always check your answer. This is actually equal to 0. Okay, this is equal to 0. Then you can check, right? Positive 4 times negative 1 should give us negative 4. Positive 4 minus 1 should give us what? Positive 3. We factorized that correctly. Remember, we're not done. We're trying to solve for y. Therefore, okay, according to the zero product principle, we can say that y plus 4 is equal to 0, okay, or, okay, y minus 1 is equal to 0. Therefore, y is equal to negative 4 or y is equal to 1. So do you see, we've basically solved for our y. Okay, please let me know if you want me to do more questions on how we're supposed to factorize your trinomials. Right, let's look at the last one, second last one, question 8.2.2. Right, it says we're still trying to solve for y. Same thing here, right? If you've got a fraction, right, got 4y plus 3 divided by 5, 5y minus 12 divided by 1, okay, right? So here, just divide, just multiply all through by the lowest common denominator. In this case, it's the lowest common multiple, right? Right? So here, what I'm going to do, I'm just going to multiply that by 5. Multiply even the right hand side by 5. So if I multiply the left hand side by 5, do you see that this 5 cancels? Then you're left with 4y plus 3 is equal to. Then if I'm multiplying this whole term by 5, it's the same as saying 5 times 5y minus 12, right? Then I've got 4y plus 3, which is equal to 5 times 5 is 25y. Okay, and then 5 times negative 12 is negative 60. Okay, then from there, I just want to add my like terms. Okay, so, okay, even if you want to just take everything to one side so that it's not a lot of jumping, you know, and then you make mistakes. I'm just going to take everything to one side, okay, just for that reason. It's 4y plus 3 minus 25y minus 60, which is equal to 0. Then I'm going to add my like terms here. You can see that the like terms, it's 4y minus 25. It's going to give me negative 21, negative 21y, and then positive 3 minus 60 minus, sorry, I made a mistake. So it's negative 25, okay, and then positive. Let's just fix that. So it's 4y plus 3 minus 25y, okay, plus 60 is equal to 0. So positive 4 minus 25, that gives me minus 21y. Then positive 3 plus 60 is plus 63, which is equal to 0. Therefore, from here, you can see that if I want to solve for y, okay, I can just say this negative 21y is equal to negative 63. And I divide by negative 21, divided by negative 21, y is equal to negative, and negative gives us a positive. 63 divided by 21 is 3. And that is your final answer. Right. Then last one, it's a problem solving situation. Right. So with this problem solving question here, right, they're saying when the object ST is inserted into a computer program, the program reads it as, okay, T squared plus ST. Right. So it basically means that, you know, st, right, the computer reads it as t squared plus st. Right, then they say if the program is given for x, right, so the program is, if the program is given for x is equal to -3, then what will the values of x be, assuming that the format of the program remains the same. All right, so now if basically what this question is telling us, right, it's telling us that, when st is inserted into this computer program, it gives us t squared plus st. Right, so that means that the 4, right, is, because they're saying that the format of the program basically remains the same, right? So that means that the s is equal to 4 and the t is equal to x, right? Because they told us that the format of the program basically remains the same. So we can say that, oh, okay, the s is equal to 4, the t is equal to x, right? Then from there, what does that basically tell us, right? Okay, it basically tells us that we said that st is equal to 4x, which is equal to, now that basically means that your t squared plus st, I can write, okay, your t's, where I see a t, I can put an x, okay, and where I see an s, I can put a 4, right? So I can say your t is x squared plus, what, when I see an s, I put a 4x. Okay, because I've told us that the computer program, okay, reads as t squared plus st. So if I put st, this is what it gives me, right? And if the program is given for x, it gives us -3, right? That means that basically means that the s is the 4 and the t is the x, right? So meaning that if I work with this original output equation that this this program has given me, okay, I can actually write it like this if I had to write it in terms of x, right? Because I'm trying to actually determine what is the value of x. Okay, then from here, okay, if I want to now, calculate what is the value of x, right? I was even told there that this 4x, right, is actually equal to -3. So I can say -3 is equal to x squared plus 4x. Do you see? Right? So I'm going to just rewrite this. Okay, still the same thing. This is the same as saying x squared plus 4x is equal to -3. Now remember, I'm trying to now determine, right, what is the value of x. I'm trying to determine, solve for x, right? So if I'm trying to solve for x, I want to obviously move all the terms to one side. I'm going to have x squared plus 4x plus 3 is equal to 0. What am I seeing here? Now, again, factorizing our trinomials, right? Okay, so same thing here. Open up two brackets. I want to get an x squared. I'm going to say x and an x, right? The last sign is a positive. So if your last sign is a positive, then the signs that you must put in your brackets should either be a negative and a negative or a positive and a positive, right? So in this case, the signs that we're going to put is going to be a positive and a positive, because you can see that the middle sign is a positive. Everything is a positive, right? Then from here, what are the factors of 3? It's 1 and 3. Okay, then from those factors, okay, it doesn't really matter because both the signs are the same. This is equal to 0. Therefore, x is equal to -1 or x is equal to -3. All right, and we are done. Okay, that paper was, this paper was actually, pretty long based on the fact that I was actually giving some additional explanations there. Right, so I hope you guys enjoyed, this first official grade 9 lesson on my channel. I'm hoping that I'm going to be seeing more of you guys. Okay, please make sure that you are subscribed to the channel because I will be uploading a lot more, grade 9, grade 10, 11, 12 mathematics content on my channel. Right, so also don't forget to just drop a comment there down below and let me know if you'd like for me to do these additional lessons on your linear graphs, right? How you draw a linear graph using your dual intercept method, table method, point intercept method, just looking at the different concepts that we've looked at this year in grade 9. Okay, right, I think this is where I'm going to stop this lesson, but I think the take from this past paper is obviously you being able to, if you study, right, being able to understand what is happening under this umbrella of real numbers. You need to be able to know what is a rational number, irrational number, integers, whole numbers, natural numbers, okay, as well as your non-real numbers. What are those numbers? Okay, you need to be able to work with your ratios, okay, how you simplify a ratio, okay, taking into consideration that when you're simplifying a ratio, remember that you are always going to divide by the highest common factor. All right, also very important when it comes to paper 1, be able to use or find prime factors using the ladder method or using prime factorization, okay, to find the LCM as well as the HCF, right? So remember, okay, when you want to find the highest common factor, circle the powers that have the same basis, and you're just going to focus on the powers with the lowest exponents. If you're trying to look for the lowest common multiple, circle the powers that have the same basis, but you're going to focus on the powers with the highest exponents. Then you just multiply them together for you to get the LCM and the HCF. Another thing here, when it comes to being able to evaluate an equation without the use of a calculator, please, they want you to show all these steps, how you simplify the numerator, the denominator, right, to get to your answer. Please make sure that you're going through your exponential laws. Okay, all right. When I'm multiplying powers that have the same base, what happens? If I'm dividing powers that have the same base, what am I doing? If I am, supposed to use the power rule, okay, how am I supposed to use that power rule? Okay, if I've got a negative exponent, how can I make that exponent positive? Right? Please make sure that you are revising those concepts thoroughly. Right, also remembering how to get the rules for your linear pattern with a constant difference or a constant ratio. How did we work with those different scenarios? Right, and okay, right, working with algebraic expressions, right, being able to identify what makes a term. Remember, if you've got a bracket, you've got terms in a bracket, okay, that counts as one term, right? How, if they ask you what is the coefficient of something, you remembering that if I want a coefficient of a particular variable, I must ask myself, what must I multiply that variable with to get that original term, right? And also, if you're simplifying, right, remember when you're simplifying, you're thinking of taking out the highest common factor, right? It can be, a common bracket. It can be a common variable. It can be a common, right? Remember those concepts there. Also, factorizing by using difference of two squares and things like that. You need to remember those concepts, please. All right. Also, if you are adding or we're trying to solve for y, or you're trying to solve for an unknown variable, right, and you've got a fraction, you need to remember, okay, that you need to multiply right through by that lowest common denominator. All right, so please take note of that. Right, please also remember this question paper is just for us to just remind us of concepts that we need to know before we enter our paper 1 session. All right, okay guys, I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.